This is the screencast for Chapter 4.6, Example 4, Analyzing Non-Negative Periodic Functions. In other words, we're going to throw an absolute value around some trig functions and see what happens. Different than squaring functions like we did in the previous example. Squaring functions will change every single value, obviously except for 1 and 0, because 1 squared is 1 and 0 squared is 0. Absolute value is only going to change the negative numbers. So we'll start out here with example 4, part A. Find the domain, range, and period of each of the following functions, and then sketch a graph of showing 4 periods. Well, before I identify the domain, range, and period of the tangent function, I want to make sense of it a little bit more by plugging in some values and seeing what's happening. So f of 0 is going to be the absolute value of the tangent of 0. The tangent of 0, let's see, sine over cosine, sine of 0 is 0, sine of 0 is 0, cosine of 0 is 1, so the tangent of 0 is going to be 0. Absolute value of 0 is 0. F of pi over 4, that is going to be the tangent of pi over 4. Absolute value of that. Tangent of pi over 4 is 1, absolute value of 1 is 1. Let's see, f of pi over 2, the absolute value of the tangent of pi over 2, tangent of pi over 2 is actually undefined. So instead of getting a point here, we're going to have vertical asymptote at x equals pi over 2. F of 3 pi over 4. So the tangent of 3 pi over 4 is going to be very similar to the tangent of pi over 4, but negative. However, the absolute value turned it to be positive 1 again. Then f of pi, the absolute value of the tangent of pi. Tangent of pi is going to be 0, and the absolute value of 0 is 0. So here we have the points 0, 0, pi over 4, comma 1, pi over 2, vertical asymptote, 3 pi over 4, positive 1 again, and pi, comma 0. So we've made sense of this function a little bit, and now I can actually see that the domain of this function is going to be all real numbers except pi over 2, well, x equals pi over 2. The next one is going to be out here at, let's see, this is pi, so 3 pi over 2. And then that one, following the pattern, the next one out is going to be 5 pi over 2. The range of the absolute value of the tangent function is going to be 0 to infinity, including 0, because we will have values that produce or output 0. The period of this function is pi, the same as the original tangent function. It does repeat itself every pi, but instead of having the tangent function swoop down below the x-axis, it bounces back up and still repeats itself after pi units. Now example 4b wants to look at the absolute value of the sine function. I'm going to approach that the same way for note purposes. The absolute value, I should change to green. The absolute value of the sine of 0. The sine of 0 is 0, absolute value of 0 is 0. There's your point, 0, comma 0. The absolute value of the sine of pi over 2 is the absolute value of 1, pi over 2, comma 1. F of pi is going to be the absolute value of sine of pi. Sine of pi is 0, absolute value of 0 is 0. Then we follow up with the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Absolute value of negative 1 is positive 1. Oops. 0, 0. 3 pi over 2, positive 1. And then last but certainly not least, the sine of 2 pi. And 2 pi is going to be 0. So we can see the domain is still all real numbers, which of course I prefer written in interval notation. The range of the function is 0 to 1, including both of those values, because we do have an output of 0 and we do have an output of 1. We include those in our range. And the period is pi, that we can see graphically. Now the now try problem is number 15. cotangent. Cotangent is the reciprocal of all of our tangent values. So I'm going to skip over plugging in some values, and I'm just going to use the reciprocal. So since f of 0 for tangent was 0, f of 0 for cotangent is going to be 1 over 0, or undefined. F of pi over 4, the reciprocal of 1, is 1. F of pi over 2, now this was 1 over 0, now it's going to be 0 over 1, or 0. F of 3 pi over 4, the reciprocal of 1, is 1. And f of pi in this situation for cotangent, the reciprocal of 0 over 1 is 1 over 0, or undefined. So we have an asymptote at 0. There it is. We have f of pi over 4 is going to be 1. F of pi over 2, 0. F of 3 pi over 4, 1. And f of pi, another vertical asymptote. So we can see the domain is going to be all real numbers except x equals, let's see, 0, pi, oop, forgot my dot, dot, dot. I got to show that pattern continues in both directions. So anything leading up to 0 pi, 2 pi, and that will go forever. The range of the function does include the value 0 and then goes all the way up to positive infinity. So it is bounded below. The period of this function is pi, just like the tangent function, and actually absolute value of sine function too.